All right, let's get started. So we had the homework 2 deadline. And I kept forgetting to talk about this for homework 1, so let's get this in lecture so I can say that I mentioned it. The late days. If you're using late days, you can, of course, submit late up to 4 days total throughout the semester. I assume you all know how the late days are working. But you can submit to Autolab. Autolab accepts submissions till Friday morning at 9 a.m. if you want to use all 4 late days on a single homework. I think homework 2 and homework 3 are the best investments for late days. So no, nothing bad about using late days on homework 2, especially. I wouldn't use all of them because I would want to save some for homework 3, but hopefully, only a few of you used late days on homework 1. So hopefully you have all 4 of them coming into homework 2. If you want to use late days, you submit to Autolab late. And that's all that's officially required that you absolutely have to do. But there is a form. If you go to Piazza, there's a pinned post that links a form to let us know that you're using late days. Please, just asking nicely, use that form if you're using any late days. That's not the official, this is what means you use the late day. As soon as you submit 1 second after the deadline, you've used the late day. So don't think that not filling out the form, you're going to get away with not being charged a late day. But what the form does is lets us know. It notifies the TAs. One of our TAs, Lana, set it up to automatically notify all of us when there's a late submission, which means the TA who's grading your submission knows that, oh shit, if I already graded this one, I got to go back and grade the new one. So if you don't fill out that form, you're likely to have some issues with grading, where your late submission might not be graded. After grades come out, you have to send a few emails or talk to me after class and stuff like that. Then we'll go, oh, we didn't see your submission because you didn't fill out the form. Then find your late submission. It's going to be a longer process to get your grades back. So if you fill out that form, it just makes all the logistics easier for all of us. You'll get your grades on time. We'll get your stuff graded. We don't have to go digging through Autolab every time to see the new submissions. So fill out the form just to make everything a lot smoother for all of us. And I think I always forgot to say this in lecture 2. Maybe I remembered one time. But if you submit, we'll get grades done by Monday morning. My grading deadline for my TAs and all my courses is 1 week turnaround. If they don't get a 1 week turnaround, I'm mad at them. So if you don't get your grades by Monday morning, 9 a.m., if they're not posted on Autolab, you know that I'm mad at TAs and I'm yelling at them and I'm at the very least in our Slack channel saying, WTF, where are the grades? So Monday morning is when we get grades out at the latest, which, especially if a lot of you do use all 4 late days, it's still kind of tight. But we're making sure that we get that, hit that goal. And then if you use a recovery opportunity, this is something I didn't really make super clear, especially on day 1 or in the syllabus. But if you use a recovery opportunity, you get a 1 week extension. Well, 1 week is our grading deadline, so that doesn't really help you, right? So if you need a recovery opportunity, that 1 week extension starts 9 a.m. on Monday, April 9th, if you're using it for homework 2. So it doesn't start until you get your grades. Once you get your grades, and if we do grade a little bit early, you just get a little extra bonus time. Once you get your grades, that's when I go through all the recovery opportunities, charge your recovery opportunity. I'll open up the recovery opportunity submissions on Autolab, which anybody could submit to, but there's no point to if you already have credit for both learning objectives. And then your deadline would be April 10th. At 9 a.m. That would be the recovery opportunity deadline if you're using a recovery opportunity on homework 2. So just to make things clear, if you're wondering, it didn't apply to very many people on homework 1, so it wasn't too big of a deal. But for homework 2, just suspecting that it's going to apply to more of you. So let's make sure we get the logistics all understood. We all know what's going on. Because the way it's worded in the syllabus, it would be a 1 week extension from the deadline, which would put you right at the grading deadline, which isn't very helpful. You'd almost automatically have to use 2 recovery opportunities to make them useful. So that week during grading doesn't count towards your recovery opportunity. You get that, I guess, a free extension, but you don't know if you have to work on it or not. I guess if you do know that you have to work on it, you get 2 week extension. Like if you just straight up didn't finish homework 2, the learning objectives, you get an extra 2 weeks for using 1 recovery opportunity. or 2 recovery opportunities if you didn't get learning objective 1 or 2. And recovery opportunities are on a per objective basis. So if you didn't get anything for homework 2, it's 2 recovery opportunities, 1 for learning objective 1, 1 for learning objective 2. So hopefully that clears up any questions that were out there. I don't know if anybody had questions. Maybe y'all knew this already, but are there any other questions about that since we just had a major homework deadline? I want to make sure we get all the logistical questions out there. How would the recovery opportunity work? It's all automatic. So that's the logistics of it, but it's all automatic on my end. Like once you see your grades, if you don't have 2 or greater for both of the learning objectives, you know that you're using a recovery opportunity. And I think it's safe to go into here, right? I'm not going to dox anyone. And there is recovery opportunities used. If you go down to stats on the bottom, which some of you might not, the lecture questions kind of push this down so far. Maybe, I guess you have to scroll down here to get to the lecture question for the day. But recovery opportunities used, you'll see it pop up there. I'll process this Monday morning, hopefully. I don't know, at the latest Tuesday. But I'll process them. You'll see your recovery opportunities used just to get that confirmation. But you'll see your grades. You'll know if you need to use a recovery opportunity or not. And you don't have to tell me, hey, I'm using a recovery opportunity. I assume you're going to use one because the alternative is just failing the class. Like I assume you're going to use the recovery opportunity. So it's all automatic on your end. Once you don't get 2s or greater for both learning objectives, you know that you have that extension and that you'll submit. I'll create the homework 2 recovery opportunity just like this. The deadline will be set to the recovery opportunity deadline, so there shouldn't be any ambiguity on that either. You'll know exactly how long you have for your recovery opportunity usage. If anybody needs 2 recovery opportunities for the same objective, I'll just work with that particular student. I'll email you and be like, hey, you need to use a second one instead of changing the deadlines. If I submit today, would that be a second late day or a third late day? Oh man, I got to do math. Okay. The deadline was, so even if you submit like 9:01 a.m. on Monday, that would have been 1 late day, even like 1 minute late. So submitting on Monday after 9 a.m. would be 1 late day, Tuesday 2, Wednesday 3. So if you submitted right now, it would be 3 late days used. Yeah. Oh, good. Yeah, good question. I never made that clear. No, the late days are per assignment. So even for the application objective, it's for all 5 objectives. Use 1 late day. You can submit all 5 of them late. Yeah, no, that would be 3 late days. Yeah. If you submitted this morning before 9 a.m., that would have been 2 late days. But since we're after 9 a.m., we're on the next day. And if you just look at the deadline, so the deadline's 9 a.m. If I want to move this deadline by 24 hours and use 1 late day, it would be Tuesday morning. If I want to move it 48 hours and use 2 late days, that would be this morning, but morning, 9 a.m. After 9 a.m., it's going to be on that 3rd late day with an effective deadline of tomorrow morning at 9 a.m. If you use a recovery opportunity, does that automatically use your late days? No. And this is where things get a little tricky, and you have to do a little bit of careful tactical planning, whether you want to use a late day or a recovery opportunity. Like if you're not done with the learning objectives, if you're still working on the learning objectives for for homework 2, you might want to just use the recovery opportunities, even if you didn't do either objective. Use your two of your recovery opportunities and then save your 4 late days. Unless you can use like 1 late day or 2 late days and get them done and not use the recovery opportunity. But you don't want to get in a spot where you burned up all 4 late days and still have to use a recovery opportunity or 2 on the same homework. You might want to just keep those late days in your pocket and use recovery opportunities. If you're on the application objectives, then the decision's a little easier. You either keep working on the application objectives or not. You use some late days and work on them or just don't. But there is some trick with that. But if you use a recovery opportunity, no. If you didn't make a late submission, you don't automatically lose all your late days. So yeah, there's a lot of decisions you can make to plan that out, however you want to organize it. But if we get a submission for you that's late, you're going to be charged late days. Unless, if you make a late submission, like especially after what you just heard me say, you're like, oh crap, I didn't know that's how it worked. You can shoot me an email and say, I don't want that last submission to count because I don't want to use my late days. Can you grade my on-time submission, and then I'll use a recovery opportunity if needed. Shoot me an email, and I'll go into Autolab and delete the last submission so you don't use up, oh my goodness, so you don't use up your late days. Or even the questions that some of you had, confused on whether today would be 3 late days or 2 late days. Like if you're like, oh shoot, I didn't know I was using 3 late days, just let me know and I'll ignore your latest submissions. Just let me know which one you want is your latest one. Especially for, like, if this cleared up confusion. I might not do that on homeworks 3 and 4, just because you all know by then how it all works. But right now, I think a lot of you are making these decisions. So if you were confused on how it works, I'll be pretty lenient on this one. Any other questions on anything? Yes. That is all. So is it okay if you post, I get this question a lot. I think I have to add this to the homework description. If you post a comment with no image, it's okay if the image looks like a broken image. That's perfectly fine. We're not going to test for that. We're not going to take any points off for that. Nothing. It's not something we're going to look for. How we're actually going to test is we're going to submit a comment and an image. And if that all works fine, we're not even going to test with just a comment. We're only ever going to test with just a comment if your comment and image combined crashes your server completely and just doesn't work at all. Something with the file uploads is causing a bug in your code. Then we're going to test with just the comment to see if we can give you LO1 credit, even though you lost your LO2 credit. We'll try to give you that partial credit, and that's the only reason we'll ever test with just a comment. And if we test with just a comment and the image shows as a broken link, that's perfectly fine. But we don't expect you to do that, to check if there's something wrong with the file or the file doesn't exist, to change your HTML template based on that, to have a conditional in your template. That's not an expectation that I have of you, that I have for grading for the homework. Actually, that would give a way to have a conditional in the template. I won't change it this semester, obviously. The deadline's already passed. But yeah, actually, that does give me an idea. Maybe I should require that in future semesters, just to get a conditional in the template. Because I talked about conditionals in the templates, but then I never make you use it. Same with loops. Most of y'all don't use loops in your templates either, even though I cover it. You don't do that. You just do placeholder, and then you generate all the HTML in your Python code, and then replace the one placeholder. You'd do the same thing anyway, wouldn't you? Even if there was a conditional, it would just be a Python conditional. Oh well. All right, if there are no other questions, let's move on with today's content. So we're continuing our conversation about WebRTC. So WebRTC, we saw the demo last time. We want to, we're not ready for this yet. So homework 3, just to give the roadmap of where we are. LO1, LO2, AO1, those you can all do. That's all WebSocket stuff. I'm done talking about WebSockets unless there are questions about WebSockets. I'll be happy to answer them. I'll be happy to talk about it. But by default, I don't have any more WebSocket content planned. Actually, next week we have some time. I might finish that WebSocket demo. I still want to manually look at the bits of a WebSocket frame and talk about it with a live example, but no other concepts to cover. Only examples that might help you out on the homework. But WebRTC, we got a lot to talk about. After today, we're going to be able to do AO2 and AO3. This is the rest of the content. Actually, AO3 might be a little tough after just today. You might want Friday's lecture as well. In AO2, both of these are about WebRTC. AO2, you have the assumption where you can assume that there are only two clients. There are two people connected to your website using WebSockets, and then when they try to negotiate a WebRTC connection, whenever you get a WebRTC message from one client, you send it to the other one. Whenever you get a message from this one, you send it to the other one, which keeps things pretty simple, pretty tame on the WebRTC side. Honestly, there's a bit of work to do to figure out what the hell to even do on this one. But once you figure out what to do, the coding itself isn't much. I think I got mine done, and I'm always hesitant to say lines of code because then everybody takes that as solid gold, like that's the number of lines you have to have. But I think I did mine in like between 5 and 10 lines of code was this one. Depending on how your server's set up, you may or may not be able to pull that off. But I would expect most of you to be able to do this in like 5 to 10 lines of code. AO3, not quite the same. Figuring out what 5 to 10 lines of code to write, actually, maybe a little more than that. Figuring out which lines of code to write is tough, but not too bad. I don't know. You'll find out. You'll have your opinions. You can let me know. And then the next one, it's the same thing, except we're removing the simplifying assumption where there can only be 2 clients. Now there can be any number of clients, though I worded the testing procedures carefully to say there will be exactly 4 in testing. So we're going to have 4 clients. There are certain things that having a fixed upper bound to the number of clients can just make certain things a little easier, a little less tedious. So it should, be able to handle any number. But if it handles up to 4, I'm going to be okay with that. Once it handles up to 4, that's a proof of concept that you can write code that can handle any number, and I'm okay with that. But this gets a lot trickier. You have to do some more routing, and this will require modifying the front-end code. You have to go into the JavaScript for WebRTC and modify how that works, because there's a lot of extra complications to it. On Friday, I'm going to go through that front-end code. I'm going to scroll through the JavaScript and explain what all of it does. It's going to go quick. There's a lot there. You'll still probably have to study it a bit to get application objective 3, but we'll talk about that front-end code on Friday. Today, we want to talk about the rest of the back-end code. Can't stretch my hand out that far. Today, we'll talk about the rest of the back-end code to be able to implement WebRTC. Can you demo the WebRTC stuff in Firefox to see if add stream? I did test in Firefox. It did work for me. I'll be happy to demo it. I don't think I checked for the deprecation warning, so we'll check for that right now. We can use my tab here. Localhost 8000 WebRTC. Hi. Well, we can do that later. So I'm in a meeting with myself. I'm leaving the echo. Oh, yeah, I demoed that there. So I'll kill the server. I'll really kill it. Server's dead. We can still hear the echo. And it's still working. And we'll see a little delay. This one is the live one for... Okay, I gotta stop the echo. I don't know how to on Firefox. Never mind. This one's the one for this tab, and the other two are the ones for the other tabs. So you'll see a little delay between the top one and the other two. Just to prove that it is going across the tabs. The echo is really driving me nuts. But the server shut down and is still working. It's true peer-to-peer. This is a peer-to-peer connection. And let's see what happened in the console. RTC ice server.url is deprecated. Use URLs instead. WebRTC. So there's some deprecation warnings, but not errors. So that's good. Giving ice configurations. I think I did see this in my IDE as well. And if I close the other two, I won't get the echo. There we go. I think I saw that warning in my IDE as well, and I did what any developer does and ignored warnings. So I'll have to look in that and fix it. I think it's the format of the ICE configuration, I believe, is what it was complaining about. .url, use URLs. Oh, yeah, okay, that makes sense. I can fix that next semester, not this semester. ICE, no, it is ICE servers. What was it mad about? Oh, .url. So this should be URLs, and then it wants a list of URLs. Okay, yeah, I can fix that. It just doesn't like the formatting. But luckily it's a warning and not a error, so things will still work. Oops, that's the wrong one. I'm all over the place. I got too many windows open. Can you explain the line in AO3? Note that all of the users will be playing the same video with the same camera since they are all in the same device. Not sure. Just like what you saw, like I had three tabs in the same meeting, but they all used my camera on my laptop. So it was me on all three. It was exactly me. Instead of having, like, if you actually join a Zoom meeting, you're obviously not sharing a camera. You have cameras on each device of everybody who's connected. So that's just what I mean. You're going to see yourself multiple times when you're doing the testing. No, you don't have to use two different camera connections. I'll have to check out that link after lecture. But you don't have to set it up for two different cameras. I actually tried setting that up, and I had a whole bunch of headaches doing it. The browsers had permissions issues, and I don't know. I forget what exact issues I had, but it was frustrating and exhausting. I'm not going to make you go through that, because that's not the use case anyway, where we would eventually have actual different devices connected over the internet to be able to use WebRTC. So doing a bunch of debugging to get it to work with two different cameras on the same device is no reason to go through that. All right, so let's talk about WebRTC. So this is a real-time streaming peer-to-peer connection, and we're going to see a few issues with this. Two big issues that we're going to see that we have to solve is the peers need to know the IP addresses of the other peer, and they need to agree on all the details of the connection before they connect. So the two peers, as it turns out, can't just connect over the internet. Well, can, but there's some logistical things that get in the way of this. So this is overall what we want to set up, what we want to do, what we want to happen, is that one peer is going to send what's called a WebRTC offer to the other peer that they want to connect to. And this offer is going to contain a lot of information about the eventual stream. There's going to be the encodings used for audio, video, if it is audio and video, or just audio, just video, what the bit rate's going to be, all the codecs being used, all the information that they need to make sense of the bytes that are eventually going to be sent over this stream. As we know, bytes can encode whatever we want them to encode. We've seen ASCII text, we've seen UTF-8 text, we've seen images, we're seeing WebSocket frames. So all this information is saying, okay, you're going to get some bytes. You're going to get a bunch of bytes from me. This is what those bytes are going to mean. This is how you can read those bytes. It's also going to contain a username fragment, a UFrag, which is going to be a fragment of a unique identifier, which is going to be able to identify the other peers. The WebRTC code in the browser is going to want that UFrag, and it's going to make sure that that's for that user, I guess. And then the other client, the other peer, at when we say peer, client, and server, those three words have a lot of meaning here. I'll try to not slip up and say the right things. The other peer is going to send an answer, because there's no client and server here. There's one person initiating the connection, one person responding to that initiation, but they're equals, they're peers in this. is going to send the answer. So WebRTC answer contains the same information as the offer. It's everything about the data that they're going to send. So each peer can be sending videos in different formats, different bit rates and everything. So this answer is going to have that same information as the offer, as well as just the confirmation like, yeah, I'm game, let's do this. How are they going to send these? How do you just send a message to another person on the internet? That seems hard. Seems easy, but seems hard, depending on which way you're looking at it. So for normal web traffic, if you're using the internet and you're going through a server, you have a domain name, or you just click a link. You have a domain name. That domain name goes to a DNS lookup server. That's going to tell you the IP address for that domain. And then you send a message to that IP address over ports 80 or port 443 if you're using HTTP or HTTPS. And then that server responds to your, connects to your TCP connection. You send an HTTP request, you get an HTTP response. But you look up the IP address for that server, which is usually a static IP address, meaning it's not going to change on you. And the DNS server knows how to find that IP address for that domain name. How are you going to do that with a peer-to-peer connection? How are we going to do that? Are we going to have everybody you want to connect to register their IP address at a DNS server and then look them up by name? I don't know. We're not going to do that. But and even worse, your IP address and port number are constantly changing. You see, whenever you're debugging, if you're printing out the port number, even though you're always localhost, your port number changes for each TCP connection that you establish. Whatever your operating system and browser choose, whoever's even making that choice. I think the browser would have to be. Whatever port they choose for that connection, that's the port it's going to be, and it can be changing. And your IP address can change as you're walking around campus. As you drive home, you're going to have a different IP address from home as you do from campus. So it's constantly going to be changing. You have to have any peer you want to connect to constantly be keeping tabs on where you are to be able to get your IP address. It's a pain. So we're going to go through a signaling server. So even though we're eventually going to get to a true peer-to-peer connection, we saw that. We did the proof of concept. I shut down my server, and everything still worked. It is a true peer-to-peer connection eventually, but there are servers involved to establish the connection. So we're going to use a signaling server where both peers connect to the signaling server, and the signaling server is going to route these messages to the other peer, which doesn't fully solve the problem, but at least gets part of it. So the signaling server is going to have a fixed IP address with a domain name. You connect to it just like any other web server, and then establish a connection with the server, and then tell the server, hey, can you send this offer to this other client? And the server says, sure. And the client says, hey, can you send this answer to the other client? Sure. And forwards those messages to the other peer. Well, they're clients and peers in this example. This is what you'll do in your homework. You're basically going to be a messaging service. You're going to get messages from clients and send those messages to other clients, and then those clients are eventually going to be each other's peers once they establish their connection. So this is what you want to do. Whenever you get a WebRTC message, you're going to forward it to somebody else. You're just a delivery service of messages. That's all your signaling server is going to do. That's all you have to do in your homework. I shouldn't say it like that. It can get tricky. But that's the only part of this that you're going to be implementing. So we have one kind of a problem here. We need to, not really a problem, but we're going to need to send these messages in real time. When we get a message from one client, we're going to send that message, we need to send that message to the other client without having an HTTP request from them to respond to. We need to just send a message from our server to a client. Unprompted, we just have to send them a message. This is a big problem, right? Well, no, not at all. We just worked pretty hard to implement WebSockets, and that's exactly solving this problem. So really convenient that we had WebSockets the week before we talk about WebRTC, because we need some answer to that. We could use long polling. Long polling works here as well, but it's more painful to set up. So WebSockets, we have them set up. you did them in LO1, well, you will. I'm sure a lot of you haven't gotten to this quite yet. LO1, LO2, and AO1, you set up your WebSocket server, your server to be a WebSocket server, and now you can use that WebSocket server to negotiate these messages for the WebRTC connections. So you'll have users connected through WebSocket connections, and they'll send the WebRTC messages through those WebSocket connections, and you can broadcast, or not broadcast, but you can forward those messages through the other WebSocket connections of the other clients. So really convenient, we got WebSockets. It's almost like that was planned out. It's almost like we can't talk about WebRTC until we solve that problem, and we just solved that problem, so now we get to talk about WebRTC. So when we get these WebRTC messages, that's going to be the payload of the WebSocket frame. We're going to extract the payload of the WebSocket frame and then figure out who to send that message to, assemble a new WebSocket frame with that contents of that message, and then send it to the other person. Any questions so far? Oh, my phone went to sleep. Can't see chat. Any questions on this so far? Okay, but we still didn't quite solve the problem of the peers don't know their IP addresses. So we want to solve this one as well. So when they connect to each other, they don't know to send their public IP address to each other in their offer and accept. I suppose, well, it wouldn't really solve the problem, but I suppose a signaling server could look at the public IP and port and send that to each other. It wouldn't solve the whole problem, though, anyway. I never even thought of that. The signaling server could act as, could solve this problem partially. Anyway, so clients don't know their IP addresses. Seems pretty simple. Like you should know your IP address, but clients actually don't know their IP address, which is a little bit of a problem. The reason why this is like this is because we have something called NATs, Network Address Translators, and this is a way to let multiple clients share a single IP address. So for your home internet, UB has a ton of IP addresses, and you get your own IP address on your machine. But at home, when you have your ISP that you're paying, they give you one IP address. You get one public IP address, and then your router uses that one public IP address for multiple devices by using a network address translator. So you get a local IP address for your device on your local network, and then you connect to your NAT using some port, whatever software you're using or whatever. And then the NAT is going to translate that into your public IP address on some port of its choosing. So when you talk to the outside world, you have a different IP and port than you do on your local internet. This way, this public IP address, you only need one per household, and then the NAT is going to have different IP addresses for your local network. So these machines don't actually know their public IP address. So we need some way to be able to communicate that public IP address that we don't know to the other client. Now, if you've ever had this problem before, you go to Google, you type "what's my IP address," and it'll tell you. And the way it does that is it pings a web server, and that web server just reports what IP address your message eventually came from. So you can't see your public IP address, but you can ask somebody on the outside world, "Hey, what's my IP address look like to you?" And then it'll reply with that IP address. Without accessing an outside server, you have no way of just finding that out just from within your local network. I mean, I guess you could ask your NAT. Maybe there's some lookup that you could do, but we don't really have access to that. So we're going to need to know that IP address and port. If you've used port forwarding, this actually came up in, was it Monday's lecture? Port forwarding. This is the problem port forwarding is solving too, is you don't know your local IP address, you don't know your public IP address, and nobody from the outside world knows your local, did I say that wrong twice? You don't know your public IP address, and people in the outside world don't know your local IP address. So they don't know how to connect to your machine. They connect to your, so if you're running a server, there's a Minecraft server. We might as well just talk about Minecraft again. With a Minecraft server, it's going to have a specific, I don't know what the Minecraft port is, but Minecraft has a port that says if you're going to run a Minecraft server, this is the port you're going to use. You use this port. And then they connect to your public IP address on that port, and what does the NAT say? I don't know. I don't have any connections on that port. I didn't communicate to anybody with that port. So what port forwarding says is, hey, NAT, if you ever get a request, any information, any TCP connection or UDP connection, any connection at all, on this port, send it to my desktop that's running my Minecraft server. So that's what port forwarding is doing for you. It's getting around this NAT problem. If you just had a public IP address for your device, you wouldn't have that problem. You wouldn't have to do any port forwarding. But when you have a NAT, when you're behind a NAT and you only have one public IP address for multiple devices, port forwarding says, this port, send it to this device. Our solution for WebRTC is using a stun server, which is largely what I described. You're going to ask an outside world. It's what myIPaddress.com is kind of doing for you, but this does a little bit more. You're going to ask this stun server, hey, what's my IP address? And it's going to tell you your public IP address and the port that you connected to that stun server on. Stun server is going to say, hey, here's your connection details. This is what you look like to me. I don't care what your local IP and port are. This is the IP and port that your NAT is using for you, for this specific connection. So each client, eventual peer, is going to talk to the stun server, a stun server, and get their public IP and port. For our purposes, we're going to use one of Google's free stun servers. We're not going to, maybe someday I'll have students implement their own stun servers. I don't think so. It's a lot of networking details that doesn't really belong in this course. And I don't fully understand them either. I'm slowly learning more and more about how stun servers work, but it's kind of magic. So we'll connect to this, and this is hard-coded in the JavaScript, the handout. You can see where we're adding that stun server. It was actually the ICE configuration that we just saw that in Firefox was coding in this URL, where it wanted a list of URLs instead of one hard-coded URL. So we're coding this URL in there, and then using that stun server to get our public IP and port. Once we have that public IP and port, each client is going to send us their candidates, which can be multiple, that can be plural. And they're going to send those candidates to each other. The candidate contains some important information about the eventual connection, including your interactive connectivity establishment information, which is your IP and port and protocol of that eventual connection. And they can send multiple. I've seen in my testing a lot of times, pretty consistently, the server sending the oh my goodness, offer. There's so many different words for this for every protocol. The offer, the client sending the offer typically send 2 candidates, and the one sending the answer was sending 1. I don't know if that's consistent or anything, but you can expect any number of candidates to be sent from each client. So they're going to send the candidates, and your job as a signaling server is to forward these candidates to their destination. And these candidates contain the IP, port, the protocol, which will be UDP. We talked about this last time when we want to stream data like this, where it really needs to be real time and you're communicating with each other. We're using UDP, and that UFRAG, which will be consistent with the offer and the accept. It'll be the same UFRAG for each client. Each client's going to have their own UFRAG, and it'll be consistent for them. And then, so after your signaling server forwarded all these messages and everything was routed appropriately, these 2 clients, there goes my lead-in, but these 2 clients are going to become peers of each other and start the peer-to-peer connection. So, it's just reiterating everything. These will become peers. All of the servers step out of the way. They could have been using different stun servers. The stun servers, if they're different, or the same. They step out of the way. The signaling server steps out of the way, doesn't do anything after that initial connection is established, and the peers have a peer-to-peer connection. Part of the magic, I mentioned that the stun server is magic, but everything I described about them doesn't seem too magical, so I want to clarify that a little bit. I'll say it right here, is when you connect to the stun server, it's not enough for it to just say, this is your IP and port of how you appear to me, because if it just said, that's how you appear to me, and then when the client tries to start this peer-to-peer connection over the same port, like the IP address is going to be the same. They're pretty stable. Like my IP address at my house hasn't changed in years, but the port, well, that's not true if you're walking around. That's only true for like a desktop, I guess. Not true if you're walking around campus. But the port can change. Every time you create a new connection, your NAT can choose whatever port it wants. So the port's going to be different when you start this new connection, which is a different connection than the connection from the stun server. So where the magic comes in, where I don't fully understand what stun servers, is you connect to the stun server, and you reuse that same connection. The stun server hands that connection over to the other peer and says, you're the other end of this connection now, which just seems crazy to me. I don't, someday I might understand that. But so to the NAT, it's the same exact connection. The NAT doesn't get a chance to start a new connection from the connection from the stun server and moving over to the client. That just is negotiated by the peers and the stun server without the NAT's involvement and without the NAT having a chance to change the port, which, I don't know, just it seems wild to me that that's even a thing. It's something I have to just dig in and study and see exactly how that works with a deeper dive than I've done so far. But that's where the magic comes in with stun servers. But now we have a peer-to-peer connection. We're doing great. So your role in this, how does IP work with mobile networks? I mean, off the top of my head, I don't know, but I always assume that it just works the same way. Like the cell tower distributes IP addresses to everybody. I don't know if the cell tower acts like a NAT at all. But it has to work the same way. I mean, you use web technologies on your phone. It's got to work somehow the same way. But I don't know if it's individual IP addresses for each connection or if it's acting like a NAT. I just don't know. So for the server, we need to send the correct things to the correct people. It's not as simple as sending whatever we get to the other peer. It is that simple for AO2. It's not that simple for AO3. You have to route things to the appropriate peer. So like for AO3, for example, you have 3 people in a meeting already and the 4th person joins in. That 4th person is going to have to establish 3 connections with 3 different people. So when they send 3 messages, you have to make sure those messages go to the appropriate peers. And then when they send like their ICE candidates, those candidates have to go to the right people. And then the responses, the answers that come back, have to get routed the right way. So it just has to be coordinated and negotiated. I'll go into more details on Friday when we're digging into the code on that one, but you need a separate connection for each peer. AO1 says we'll test with larger than 65K. Do you just use a really big, long text block for that? Oh, yeah, that's what I was doing right at the end of the last lecture. I didn't quite have time to do, but on next week, I think I'll do that. What I do is I do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I copy that, paste it 10 times, copy that, paste it 10 times, copy that, paste it 10 times, and I lost track of where I was at. But I do that till I'm at 100,000 characters, then I click send. And then we go over 130, so the last 100,000, copy and paste like 3 times to get a 300,000 bytes, then click send. What's surprising, I mean, computers these days handle that like a champ. There's almost no delay. Like when I click send on 300,000 bytes, it just appears. It's wild how fast computers have gotten. That's not even a big deal to our machines these days. When our machines can do billions of calculations per second, they just don't care about hundreds of thousands. Yeah.
So when do you close the connection?
There is, but we're not going to worry about it. So there, and I have that in a slide somewhere. I don't remember which slide it's on. But there is a way to close an RTC connection, a WebRTC connection that can go through the signaling server. We're not going to worry about it for our purposes. The clients can figure it out themselves how to close it. But you can send it through the signaling server. And yeah, we're doing all this through WebSockets. So, important note on WebRTC is WebRTC does not work over HTTP. So be careful about that. If you're connecting to the signaling server using HTTP, which of course we are, WebRTC is designed to just not do that. WebRTC needs an encrypted connection to actually use WebRTC. So if you're connecting to the signaling server with HTTP, it's a no-go. Doesn't work. There's one exception to this, thankfully, or else why the hell would we be doing this before doing HTTPS, is it will work if you're using localhost. So doing your testing locally on your device works perfectly fine. So luckily, we're in luck with that. We can do our testing. We can do this assignment. We can test this assignment. We're just going to do everything over localhost. Once we do HTTPS, which is a homework 4 topic, we will get to HTTPS. Then you can use your WebRTC code, deploy it on the internet with a domain name, and have true peers over a network connection over the internet. But without HTTPS, we can't quite get there yet. So just keep that in mind. I've had students, rightfully so, who want to test this stuff and actually see it in action with 2 different cameras. You do need HTTPS for that, even if the 2 devices are on the same network. So if you have a local network and you both connect to your signaling server, unfortunately it won't work until you get HTTPS. There's one more. We're not going to do anything with this, but and I mentioned it last time briefly. I'll mention it briefly here. Sometimes you can't use WebRTC, sometimes you can't use a true peer-to-peer connection. You might have an overly aggressive firewall. Your organization might block WebRTC connections or other connections for other reasons. Or you might have a dynamic NAT, which is constantly changing your port and really messing things up with the connection. For this, the solution is to use a turn server, which routes all of your stream through that server. As I said last time, I'll say it again, that I think this just defeats the whole point. If you're using a turn server, you're not a peer-to-peer connection anymore. You can still use WebRTC, the protocol, but I don't see the point. I fail to see the point if you're using a turn server. If you're using a turn server, you're not peer-to-peer